So here is our database. Here is our database. So it's a component, and it's what it's doing to the outside world. It's providing what is known as interface or application programming interface, API, application programming interface. So typically this one is like basically it's running on some host or node in the network. It could be on the same machine or could be remotely on another machine, and it's listening on some ports. Typically the database will be listening on some ports. And what you can do, you can send it some commands, typically in SQL, and it will reply to you with some results. Yeah. So this API, this application programming interface on how to programmatically submit this query to the database and programmatically get the results from the database is very different from one database to another. Oracle will do it in one way, SQL Server in another way, and MySQL in totally different way. So the poor developers, if we leave them to the database themselves, they will be learning multiple interfaces to interact with these databases. It's not a trivial task. So luckily, most of the programming platforms that are commonly used, like Java or .NET or Python or C and so on, they provide a unified interface that us as developers, how many interfaces we will learn? One. Okay? And then each database will provide an adapter. You as developer, you talk to this unified interface, and then that adapter, we typically called the driver, will translate your interaction with this unified interface, and it will translate it to the native interface of the database. Are you following?
Yeah.
Why are we doing all of this?
To unify the API interface.
Why is this? Why are we trying to unify the interfaces?
To make the developers' life easier.
To basically make the life of developers easier. They don't have any life already, so we don't want to burden them more. So we provide them this unified interface. So usually it is a burden on the database vendor to provide such driver. Okay. And if they don't provide, there are third parties. They might sell you or give it open source as a standard interface. Yes, please.
Is it independent from the database management system?
No, basically each database has its own driver. So in Java world, what is the unified interface that we use to talk to any database in the world? In a relational database, this unified interface is called JDBC, Java Database Connectivity, Java Database Connectivity or something like this. Maybe connectivity. Okay. Yep, JDBC. Yeah, Java Database Connectivity. Yes. So this Java Database Connectivity is a standard. Some people like us set together and make up their mind. These are the abstractions we will provide to our developers. Our developers will only learn these simple abstractions and use these abstractions in their program to interact with any database. Okay. Now, to interact with this any database, what you need here, what's the intermediary here between the native API, and the standard API? There is a translation layer. This translation layer, we call it driver. Yeah. So you will find JDBC driver for SQL Server. Okay, Microsoft JDBC driver for SQL Server. And there are some third party as well. JDBC driver for Oracle. JDBC driver from Oracle. Usually the database vendor will provide this. There are other third parties. JDBC driver for MySQL. JDBC driver for MySQL. You will find it. Yes? Now, us as developers, do we need to learn the native API of each database, which keeping in mind those native APIs are different? We only need to learn one standard. Of course, that standard is different from one language to another. So in Java, we call it JDBC. In .NET, there is something called ADO.NET, or data access technology. Okay, there are in every kind of language, they have their own standard API to interact with databases, and the similar concept. So there is standard interface exposed to programmers, native interface exposed by the database, and between them there is a driver. That's basically the concept. Okay, so let me now, just because we cannot cover everything, I will just cover at least the JDBC. Hopefully some of you are already familiar with it. JDBC comes with three major abstractions, three major classes: connection, statement, result set. That's it. These are the major ones. So what you do, you establish a connection with your database. You use a statement to issue an SQL statement. You get a result set. You look through it and you extract what you want. Yes? That's basically the idea. So let me show you an example. Those are the steps. You use the connection class to connect to the database. You create a statement based on the connection. You execute a query using the statement. You process the results and you close the connection. Because remember, because this is a network, because it's remotely accessible. Your server might be in another node. And this is how it looks like. This is just a very simple example here. So what I'm doing here, I'm going here and say, this is a little bit cryptic. Let me show you another one. Very, very quick. Super quick. Here it is. So basically, I connect and then I create statement, issue as SQL execute a statement, and then get the results. Okay, so let me see if I can quickly find a quick example. Here it is. Come in. Come on. All right. While it's doing that, so just imagine I get the connection, which is of type connection. From the connection, I do create statement. I get a statement object, and then I say, go ahead and execute, and give it here. What do I give it here? A string, text, a string. And in this string, I basically put my SQL statement. It's up to me what I put there. And then what I get back is a result set, which is nothing but a tabular data structure, which has rows and columns. Because in the database I have tables, so I get back a tabular data structure. And guess what? And from now, another struggle comes to the poor developers. Because in our world of programming, usually we don't deal with the tabular data structures. We usually deal with objects. So for example, here, I have here a list of contacts, and a contact is a class. But I am getting back a tabular data structure. What do I need to do? Look through the tabular data structure and convert it to objects, and then return a list of objects to the caller. And this is how I do it. Very annoying. If we get some new team member, some baby developer, we give them to do this. Nothing. There is no value in doing this. Okay? All they are doing, going through the result set. The result set is a tabular. I go through one row at a time and read the ID, read the ID, read the title, read all these pieces of information. I need to be careful This is an int. I have to do get int. This is a string. I do get string, get double, and you see it's not that straightforward. Then based on these pieces of information, I create a new object, and then I'll add it to the list. Hopefully nothing goes wrong. I go through this, and then at the end I return the object. I return the list. Yes, there's already a little bit of pain here going on here, because basically you are bridging the conceptual gap between database and your program. Your program is an object-oriented program, and your database talks about tables and rows and columns. There is some mismatch between the two worlds, the world of database and the world of software development. So, and who bridges this gap? The poor developers with extra coding. Yeah, that's basically the idea. And it's even worse. If I have a new contact and I want to add it to the database, what do you think? What will happen? If I have a new contact object and I want to push it to the database, I want to store it in the database. How I will do so?
As a string, then plus.
So I will construct an insert statement. Insert into contact, open the brackets, put all the column names, and put values, and then take the ID plus name plus concatenate all of this. Very tedious, very error prone, no novelty there, just type it. Okay? So this is what is known as impedance mismatch. There's a big mismatch that's going on. And this is a crash course on SQL statements. This is if I want to insert, this is how I do it. Insert into and put the table name, put the columns I want to supply values for, and then supply these values in the values clause of the statement. This is if I want to read or from the database, select which columns I want, which database I want, which table I want to read from, and this is the filter condition. And this is for updating, updates, which table I want to update. This is the column and value, and I can also filter. Deleting, this is how I delete. Just very, very crash course, crash reminder of how SQL statement looks like. Now, in this world of JDBC, although it relieves us from learning the native API, we still have to do some dirty work of bridging the object-oriented world with the database world by writing ourselves and crafting these SQL statements in our code, typically using some concatenation. But we don't want to do this. We want something better. And this is where this object relational mapping comes in. Okay? So I just want to give you one glimpse and let you go on this, just to show you how it looks like in the new world. In the new world of object relational mapping, all I do, I come to my class. Can you see here my class? And I add some annotations to map my classes with my tables. Okay? That's all I do. I do some annotation to my classes. Say, oh, by the way, this class employee is mapped to table employee. And because in classes, we don't have the concept of primary key. Those of you coming from object-oriented programming, we don't have the concept of primary key. We need to teach and make the class aware that this particular attribute is a primary key. How do we do this? Adding this annotation as ID. That's it. That's all we do. We annotate our class. And then if I want to insert a new entity, just to give you a glimpse of how this works, and then I will explain it more next time. Okay, there's a lot of details. It supports relationships, it supports all of this, but just something like this. For example, if I want to find a customer of a particular ID, all I do, there is a new API. Of course, behind the scene, there is JDBC. JDBC is still relevant. On top of it, they built what is known as entity framework. All I do, I say, entity manager, please go ahead and find me a customer with this ID. And this will go ahead and generate select from customer where customer ID equal this customer ID. And guess what? It will return me an object, not a result set that I have to go through myself and extract what I need from it. If I want to persist, super simple. I create an object and I go ahead and say, entity manager, please go ahead and persist this object. That's it. And what the entity manager will do, will generate the insert statements on my behalf. So that's what this, and this is known as object relational mapping. This is a very, very widely used technology to bridge the gap between the database world and object relational world. Now, in the Java, we call it JPA, Java Persistence API. In .NET, we call it Entity Framework. Entity Framework is the entity framework. In .NET, same concept. It's an ORM. It's an object relational mapping. In JavaScript, there are many frameworks. JavaScript ORM. So loopback. Similar concept of entity framework. I take classes, annotate them, and then I'll use some API to push them to the database, get them back with data writing SQL, and with that bridging myself. For Python, same thing, you will find ORMs. So you need to understand the concept in one technology, and then you will find something similar in other technologies. And the whole idea here is take classes, annotate them, and then use some simple API to push them to the database and get them back.